Hukseflux supplies sensors to measure heat transfer and thermal quantities. Our product lines include solar radiation, heat flux, and thermal conductivity. This video offers a short introduction to heat flux measurement. Heat flux is the transmission of energy through a surface area. It is expressed in watts per square meter. Heat flux occurs whenever there are temperature differences. We are continuously surrounded by and exposed to heat flux. Heat flux measurements are used for many purposes: to increase the safety of our workplaces, save energy in our houses, improve the design of electronics, and many more. As an example, let's take a look at heat flux through a wall. If the air temperatures at the two sides of the wall are different, heat starts flowing. At a fixed temperature difference, the better the wall insulates, the smaller the heat flux. A typical measuring system measures the temperature difference and the heat flux. By analyzing a few days of measurement data, you can determine the thermal resistance of a wall. This is a heat flux sensor. Inside it, you will find a very sensitive temperature difference sensor, a thermopile. A thermopile generates a voltage output signal proportional to the local heat flux. Thermopiles do not require any power supply. Calculating the heat flux is easy. Just measure the output voltage and divide it by the sensitivity of the sensor. So if there is a temperature difference, heat starts flowing. As a first approximation, most heat flux is proportional to the temperature difference. Heat is transmitted in three different ways. The first mechanism is through conduction, through a solid or stationary fluid, for example, inside a wall. Conductive heat transfer scales with dimensions and with the thermal conductivity of a material. The second mechanism is through convection, from a solid to a moving fluid or gas, for example, from a wall to air. Convective heat transfer varies with flow speed. The higher the flow speed, the higher the heat flux. The third mechanism is through radiation, for example, from the sun to a wall or between two objects with a different temperature. Radiative heat transfer depends on the surface absorption and emission. The lower the emission, the lower the heat flux. Please remember that surfaces such as blank metals not only have a low emission, they also reflect a large part of the incoming radiation. Heat flux measurements are used for many purposes. Here are some examples. This is a heat flux measurement on a tube surface with a thin and flexible sensor. Here, a high-temperature heat flux sensor for industrial use, in this case fixed at one location. Here, configured for a mobile survey at different locations, using a battery-powered measuring system and a sensor equipped with magnets for easy installation and removal. In electrical power plants, you can measure the heat flux from the boiler wall to the steam, using heat flux sensors integrated into the wall of a boiler tube. To study fire and flames, water-cooled heat flux sensors are used. They have a black front surface that absorbs the radiation. Such sensors are also used to assess safety near flares. When selecting a heat flux sensor, first look at the application. What are the expected ranges of heat flux and temperature? Second, determine how heat is transferred: by radiation, convection, conduction, or a combination of these mechanisms. Third, look at the environment. Are there any special requirements, for example, chemical or mechanical? And finally decide how to measure the output signal. 4 application tips. Tip number 1. When setting up a measurement, you should realize that the presence of a heat flux sensor potentially affects the local heat flux. You can estimate and correct for errors or accept a certain measurement uncertainty. Tip number 2. Also be aware that heat flux sensors measure locally. Most systems employ multiple sensors to get a better picture of the variability from one location to the other and to create some redundancy. Tip number 3. If radiation plays a role, make sure your sensor surface absorption matches that of the object it is mounted on. Tip number 4. In many applications, it is not necessary to perform an absolute measurement in watts per square meter. Consider monitoring trends relative to a reference point. A brief comment on calibration. The sensitivity of heat flux sensors is traceable to international standards. Sensors are supplied with calibration certificates. Here you see a facility for calibration of radiative heat flux sensors. Here, a guarded hot plate used as a source for conductive heat flux. Heat flux measurements are used for many purposes. Would you like to know more? Then please contact Hukseflux. With 25 years of experience in this field, we have more to offer than just 4 application tips. We will assist you in choosing the right instrument for your application.